Good morning, good afternoon, good evening. Hello and welcome everyone to this past marathon. We're excited you could join us today for Navdeep Sidhu's session, 3 reasons to pick a time series platform for monitoring DevOps-driven microservices apps. This past marathon features back-to-back live webinars delivered by expert speakers from the past community. This session and all the other sessions are recorded and online after the event. You will receive an email letting you know when the recordings are available. My name is Markus Ehrenmüller-Jensen, and I'm a business intelligence architect based in Austria. I'm also the leader of the local past chapter and one of the organizers of SQL Saturday in Austria. The next one will be over in January in the beautiful town of Linz. I have a few introductory slides before I hand over to Navdeep. If you require technical assistance, please use the question pane located on the right side of your screen, and someone, probably me, will assist you. This question pane is also where you may ask any questions. Feel free to enter your questions at any time. Once we get to the Q&A portion of the session, at the end, your questions allowed to the speaker. You're able to zoom in on the presentation content by using the Zoom button located at the top of the presentation window. Please note that there will be a short animation at the end of the session. This will pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete it. Thank you to our present sponsor, Influx Data. This past marathon wouldn't be possible without their support. InfluxData provides leading time series platform to instrument, observe, learn, and automate any system, application, and business process across a variety of use cases. If you'd like to learn more about them and their solutions, please visit the sponsor page in the past marathon website, and also check out the exclusive white paper available in the hand section of the main pane of this webinar. It's 2018, is just around the corner. It takes November 6th in Seattle, Washington. If you haven't registered yet, use code marathon to save $100. We hope to see you there at this year's PAS Summit. This PAS Marathon session is presented by Sidhu. I'm waiting for the light. Yes, here we go. This is Navdeep Sidhu, and he is head of product marketing at Influx Data. Prior to joining Influx Data, he was vice president of product marketing at Software AG, where he focused on delivering platforms for building and integrating end solutions. And without further ado, here is Navdeep with 3 reasons to pick a time series platform for monitoring DevOps-driven microservices apps.
All right, thank you, Marcus, for the fantastic introduction. So welcome, everybody. Today, we will be covering the 3 reasons to pick a time series platform for monitoring DevOps-driven microservices apps. And I hope that this session is informative and useful, and you're able to learn a few things about time series platforms if you're not familiar with those kind of platforms today. And if you're already familiar with the time series platforms, then you should be able to find out more about Influx Data's time series platform, which is the leading platform in this area. So without further ado, let's dive into the content. And as Marcus mentioned earlier, we will have some questions, some polls in the middle as well, just to see what is your familiarity with these concepts. All right. Agenda is pretty straightforward. We will focus on why DevOps-driven microservices-based architectures need better monitoring, and why time series, how time series platforms deliver this better monitoring for DevOps and microservices and any of the new age architectures. And what is the need for better monitoring, and why is time series able to deliver it? And what are the 3 reasons that time series based platforms make sense? And then we will also highlight some of the components of our Tickstack, which is Influx Data's product offering. It is open source core, and we will walk you through all four of these: T for telegraph, I for InfluxDB, C for capacitor, and K for C for chronograph, and K for capacitor. So all the four components, how do they fit together, and how do they deliver the purpose-built platform for time series? And then we will also look at how different companies are leveraging our tech stack, just to give you some ideas of the use cases that we can support, and also how you can potentially use some of these time series concepts as well. So this is very important. Everybody is developing new apps today, whether it is low code, IoT driven, process driven, or microservices based apps. All the modern application architectures are replacing the legacy apps that have been in place for several decades, just because people want better usability, scalability, more responsive apps, and sometimes you have mobile and IoT needs, and some of these older apps don't work very well on the mobile devices or with the IoT sensors. So we see urgency in developing new customer-facing apps, and almost every application today is being replaced or modernized, except for perhaps some back office apps. So now there are many ways you can go about modernizing these apps. You can either get a low code platform, start building your own apps, because that's the fastest way, or you can figure out pieces of technology yourself and start building a microservices architecture, and you construct an app using these microservices. So your application could be a process-driven apps for example, for a complex mortgage application process, or even IoT-driven app where you are showing the percentage of your battery is your car's battery being charged or not, and those kind of applications which are very centered around utility consumption, electricity usage, water usage, and those kind of things, which don't involve a very complicated process, but they involve a lot of IoT driven information coming into the app. But it does not matter what kind of application you build, because no matter what kind of new application architecture you adopt, all these modern application architectures have one thing in common, and that is the need for better monitoring. So obviously the question is, why better monitoring? And the reason is there are several aspects for adopting new application architectures. And if you look across the board, there are four things which stand out why we see customers adopting new application architectures. And first and foremost is uptime. And the reason uptime has become so critical is the the application has to have 5 nines or even more uptime. And this high uptime requires sub-second level visibility into architecture. And most of the legacy monitoring tools, they do not provide that level of visibility into the architecture. Most of the tools, even the more modern ones, more recent tools, go up to a second level of visibility, but nobody is able to provide sub-second visibility into what is going on into the application. And for a lot of these newer applications, a second is probably too late. And we'll discuss more into why I say that, but let's cover all these four first. And the second one is complexity. So these new apps, they look very simple, but if you look at microservices architecture and some of the other cloud-based virtualized architecture, the older apps used to be deployed pretty simply on top of a server on a piece of hardware. But now you have different layers of virtualization. You have Docker, you have VMware, you have some microservices running, and these microservices could be a mishmash of architecture, and the parts of these microservices could be supported by dozens or even more systems across the board. So there's an inherent level of complexity when we are deploying these microservices using Kubernetes or something which is relatively new, and it needs a lot of monitoring across domain within the IT. And the third part is scaling. One of the biggest reasons companies adopt modern architectures is their older applications. They cannot change fast, they don't scale well. And scaling becomes super important. And a lot of the scaling requirements are then tied into how the infrastructure is scaling. So if you are seeing that the application is maxing out, you want to scale out. The scaling out may take 15 to 20 seconds to provision a new instance, and you want to start that process as fast as possible. So companies are looking at sub-second response time when they want to see that the memory is maxing out, the CPU usage is maxing out. So the sub-second visibility becomes even more important when you're trying to scale things. And finally, volume. The legacy systems cannot handle volumes of metrics that are being generated by the newer architectures. So in the past, for example, you had a virtual machine and you had application server, maybe a database server, and you were monitoring the health of your app server, your database server, and maybe hardware. So these 3 or 4 things. Now you have hundreds of systems, hundreds of layers in your application architecture. It has become so complex. And as a result, every layer is spitting out more metrics and events than anything that you have seen in the past. So the legacy systems cannot handle the volume of metrics generated. So before we go to the next section and start answering some of these questions, we have a quick poll. So I hope you can see the poll on your screen. And I think we have 30 seconds to respond to this poll. So please please select one of the options.
So Navdeep, 80% of the audience says no, 13% says yes.
Excellent. So that means by the end of the session, we will turn 100% of the audience into a yes. All right. So before we find out more about Influx Data, let's look at what is time series platforms, because that is exactly what Influx Data provides. So we just talked about the need for better monitoring, and also the fact that the modern architectures today, they spit out large volumes of metrics and events. So as a result, there's an emergence of time series platforms for advanced monitoring, right? So this emergence of time series platforms is due to several reasons. Some of the reasons we just covered on the last slide, but then there are more. If your app is now connected with any devices or transmitting or receiving any type of data, your legacy monitoring will not be able to support it. If your application requires any instrumentation of DevOps tool chains, your monitoring will not be able to support it. And it is not just the DevOps tool chain. When you look at the underlying cloud infrastructure and container orchestration like Kubernetes, then the amount of metrics that you need to monitor grows exponentially. So these three are additional reasons why we are seeing a huge demand for consuming, retaining, processing, analyzing large amounts of metrics and events. Just because of newer application architectures, the IoT devices, the need for instrumentation, and also the consolidation of metrics and events. Metrics and events are being generated by dozens of systems or more, hundreds of systems at times, and you need to consolidate all those metrics and events being generated by your infrastructure layer, your virtualization layer, your instrumentation layer, your Kubernetes layer, and your cloud provider, and to make sense of all of these. And this is what makes metrics and events unique. So there are common elements. Metrics and events are all timestamp data. They are generated in regular and irregular intervals. So let me just explain that point a little bit, and also distinct between the metrics and events. So metrics is something that is generated every millisecond by your CPU. My temperature is this, my cycle speed is this, so much memory is being consumed, so much memory is available. So if you go to your machine's task manager or your Mac stats, you can see all those metrics. Your computer knows what's happening inside the computer, and those metrics are being processed, logged, and also shown to the user as needed, right? And similarly, events is when you trigger something, when you open a browser, that is a user triggered event, and those are also logged within the computer systems. Now take that to the enterprise level, right? You have thousands of servers, thousands of virtual machines, several cloud providers, tons of network layers, and each layer, each component, each server, each database is spitting out metrics about the database usage, empty disk space, used disk space, network stats, logs, all types of data is being generated. And one thing common is that all this data is time-stamped. Now, this is what we call metrics. Anything that is being generated, like the CPU temperature, memory consumption, that is all metrics generated at regular periods, regular intervals, and anything that is driven by user, it could be opening up a new browser, closing a window, or placing a new order on a website. It is all events, and these are simply irregular. They are similar to metrics because they are time-stamped, but they identify a unique event that happened at a particular interval in time. And combining the metrics and events, organizations have a problem of processing huge volumes of data today. And with that, actually, we have a poll here. After this slide, we will have another question for you. But let me just make sure that we understand why time series data is different. So we just learned that time series data is all metrics and events, timestamp data, and now every layer within the infrastructure stack is producing large amounts of metrics and events. So when the data is being produced, obviously the problem is how do you ingest that large volumes of metrics per second, right? You have millions of data points being generated every second, and in some cases every millisecond. So there is no system in the world who can generate who can ingest millions of these metrics and events coming in every millisecond. And how do you do real-time queries on large data sets? So the problem is not just this, you have multiple metrics coming in from different sides. You have a Unix server, which is spitting out metrics. You have a virtual machine. You have database server. How do you tie in metrics to cross the system queries to make some sense out of it, right? If somebody says, hey, our website is running slow, how do you make sense of that website performance and correlate that with your Unix server, your database server, your virtual server, your network speed and all that, and pinpoint where the problem is, right? So there's a correlation problem, there's a real-time query problem, and there's obviously a data ingestion problem. And then there is also a problem, what do you do with the data which is old? You don't need the website performance from yesterday, you just need a high-level information that the best performance was this and the slowest performance was this, but you don't need data for each millisecond. So how do you rapidly evict and transform that data? How do you downsample of high precision data to a point that you need the sampling rate, right? You don't need the data to nth degree. You may downsample it to some level and then just keep that and delete the rest. And for the data that you are storing for long periods of time, let's say for a year or more, how do you optimize your storage and compression? Because a lot of companies are paying today to the cloud providers. So this data is probably sitting, this terabytes of data could be sitting with a cloud provider and you could be paying for it. So how do you optimize your storage and compression? And these are all the reasons why a typical time series platform is different. It is purpose built to handle time series data. And we'll find out more in a minute, but let's do the second poll here. So before joining today's session, have you heard of time series data platform before?
Hi, Navdeep. So 62% of the audience says no, 38% of the audience, actually 64 no, 36 says yes.
Okay, thank you. So those are good numbers, and I'm happy we are doing this session today. So hopefully by the end of the session, you will feel comfortable talking about time series data platforms and what time series data is and how it is different from the rest of the data. So the next slide fits in very well. So let's talk about different types of data. The first type is very structured. Orders, order lines, customers and contacts, and your typical relational data, which is related to each other, and you can link your customers to orders and orders to order lines and payments and shipments, and all that flows very well together. So there are big RDBMS out there, not a new technology. It's been around for a while, but it is very prevalent. The second type of data is all about unstructured. You have logs, web pages. One data set log generated by one system could be very different from a log generated from another system, and web pages could be generated differently as well. But you quickly need to search through all this and make sense of all this data. And then we have a search-oriented systems which go across the board. And finally, we have big data, which is all about volume variety. You can store structured, unstructured, multimedia files. You can do sentiment analysis on all this data. And this is, you can have data lakes and you can have big data stores. And finally, we are categorizing a new type of data store, which is all about time series data. So time series data, as we know, is very different, and it is also huge in volume. There are different attributes. You have to ingest it quickly. You have to process it quickly. You have to downsample it. You have to get rid of the older data that you don't need, and then you have compression and other needs from this type of data that we provide. We at InfluxData we are proud to have the #1 time series platform for metrics and events. And on the next slide, we will show you how it works. So if you remember on the first or the second slide, we talked about the Tickstack, right? On the agenda slide, we will walk you through the Tickstack and we'll show you how it works. So this is a very nice picture which shows you the Tickstack. Telegraph is the T in the Tickstack, and you can see Telegraph connects to your system stats, databases, your networking devices, your message queues, your apps. And Telegraph is more than 100 plugins. In fact, it is closer to 200 now. And these plugins, they plug into multitude of your IT infrastructure to collect metrics and events. So recently we made an announcement that Telegraph is now available for Azure Monitor, and Telegraph agents also work on Google Cloud as well. So Telegraph is the most popular choice in the industry today across the clouds, across on-prem technologies, across databases, network devices. It is the #1 choice for collecting metrics and events from almost any IT infrastructure, including messaging queues, Kafka, and whatnot. So what happens after it collects those metrics and events? So after it collects those metrics and events, they can either go into InfluxDB or they go into Capacitor. Actually, they can go into both at the same time as well. But let me just walk you through the process a little bit. So once you have collected data, metrics and events is essentially timestamp data. It's just high volume and non-relational data. They go into InfluxDB for storage and processing. So InfluxDB is the purpose-built time series database, and it can be clustered as well. And this database then stores, processes all that data. And then Chronograph on the top, which is the C in the Tickstack, is the interface for the InfluxData platform. A lot of our customers use Chronograph, and a lot of our customers use Grafana as well. So InfluxDB works very well with Grafana. And this stack, Chronograph basically allows you to do queries into InfluxDB and also process the results. At the bottom, we have K, Capacitor, which is the real-time streaming data processing engine. So what Capacitor does is it allows you to process and analyze that data that is residing in InfluxDB. So you can see the data, you can query it using Chronograph, but if you really want to set up some rules, and you can process that data. You can say if my Unix server is running out of memory and my Oracle server is running out of memory, then send me an alert on my Slack channel, right? So capacitor has all that smarts, and it can also plug into other machine learning products as well, other machine learning APIs as well, to make sense of what is going on and what to do next. So essentially, anomaly detection engine, which can process very fast moving data, fast moving metrics and events, and it can understand what's going on and alert. It also works with PagerDuty, OpsGenie, Alerta, Sensu, and bunch of other products as well. So a very vibrant, very growing, fast growing ecosystem of technologies around the Tickstack. All right, so we just covered the Tickstack, and let's move on and see what exactly does InfluxData do. So InfluxData is singularly focused on one goal. We have only one platform, and that platform is used for several use cases, but essentially we deliver modern engine for metrics and events. It's all about time series data. We as a company have, as we call it internally, a very singular focus. We want to be the best engine for metrics and events, and it's all purpose built. We are not built on top of another platform, so that means we have a very small footprint, very fast, written in Go language. We are supported on all major cloud platforms. And this picture, the next picture, is our platform strategy. It just gives you a different visual, different way of looking at things. Essentially, the metrics and events are coming in from IoT sensors, devices. Going forward, it'll be coming in from autonomous vehicles, and it is already coming in from your home devices, home automation, your appliances, and even from satellites. And a lot of this data is then correlated with infrastructure metrics, which could be your servers, your network, your speeds and feeds, and then also business metrics. How does the sensor information, how does this server information, Kubernetes information correlate with your business metrics? And then all that metrics, all those metrics and events are processed by this common metrics and events data events platform, which is InfluxData's platform. And then we provide monitoring, analytics, tracing, and machine learning on top of it. And obviously the storage, the downsampling, everything else that goes with InfluxData as well. All right, so with that, we have, I believe, another question. Let's do a quick poll here. Are you using time series platforms for monitoring today? I completely understand very few are familiar with the concept. But let's see how many people are using the time series platforms today.
Hi, Navdeep. So 93% of the audience says no, 7% says yes.
Excellent. All right, thank you. All right, so a little bit more about InfluxData, and now we will also talk here about how you can start using time series data as well. So please pay close attention. So we are open source core. Most of our products, in fact, I'll show you which products are open source. You can download them. You don't need to call anybody. You don't need to pay anybody. You can start using them today. You can put them into production as well. So InfluxData's time series platform, these are two different stats. They're kind of similar, but let me explain. There is a third party called DB Engines. DB Engines is all about database engines. They track every category. They track every vendor. So as per DB Engines, in the last 2 years, time series is the fastest growing database in the world, or the time series is the fastest growing category amongst different DB engines today. And on the right hand side, you can see that of all the available options today, InfluxDB is by far the most popular option as per DB engine. So time series is the fastest growing category, and InfluxData is the leading time series database today. All right. So very popular. Our database has been in existence since 2014, which is 4 years, and our commercial offering has been in existence for almost 2 years now. And we have received huge accolades. We have built a solid membership community of our products. And InfluxDB was announced in November 2013, and it arrived sometime in 2014. So we have 13,000 stars on Git today, and 150,000 databases in use today. And that is actually a very conservative number. Our databases have a phone home feature which we openly allow and encourage our users to turn off. So this number is only for the number of databases that phone home. So we are around 150,000 phone home databases today. For others, we don't know, but a rough estimate is probably double than what phones home. So roughly 300 to 500,000 databases on any given day. And with that, let's talk about our customer base as well. We are lucky to have some of the largest companies in the world, and we count them as our customers. And now we will talk about our approach and what do we do and what is our core focus. So it is very simple. We are not a big company. We are a fast growing startup. And as I mentioned earlier, we have a singular focus on time series data platform. And we are for developers and builders. We are easy to use, open source, easy to deploy. That is our core focus. We cater to developers, builders, site reliability engineers, architects, and technical folks. And our goal is to be platform of choice for all metrics and event workloads. We talked about this slide, and I wouldn't go into a lot more detail here, but essentially any metric, any event that is being generated by your IT infrastructure, your business, your autonomous devices, your sensors, your turbines, your solar panels, we want to be the system of, we want to be the engine. We want to be the system that processes, that stores, that analyzes those timestamp data. All right, taking the last picture to the next level, and just stay with me. I will be talking about products and everything coming out on the next slide. But this is our high-level vision. We accumulate time series data, we analyze it, and we enable our users to act on it. So Tickstack, the telegraph, tries to accumulate the data. Different agents, they bring the data into InfluxData platform. We analyze it and we act on it. So every component plays a big role of the Tickstack in accumulating data, storing data into the InfluxDB, and then analyzing data and acting on it. And you can visualize data if you just want dashboards to see how your infrastructure is performing. You can visualize that data if you want to notify people via Slack, PagerDuty, Opsgenie. You can notify them. And if you want to act, you want to invoke a service and automate the process, or maybe fork out to machine learning algorithm and learn what needs to happen next and make that decision, you can do that as well. So very powerful, scalable, extensible, all open source. And with that, we talk about our products and offerings. So this is a very simple way to look at this chart, is that if you look at the half, open source core, where it says open source core and below, all that is open source. So you can download the whole Tickstack from Git or from our website, and you can put into production today. It is very easy to learn, master, and put into production. In fact, our CTO was building monitoring systems himself when he got the inspiration to build something just for time series data. So his main goal, and we have actually trademarked this phrase, time to awesome. So our goal is to delight the developers and make sure that they feel awesome when they download our stack. So I would encourage you to download our open source core and start playing around with it and put it into production. And then as your needs grow, if you need clustering, manageability, high level of security, things like LDAP integration, whatnot. So all those come with the enterprise release as well, but we do have some of the largest companies in the world just using our open source code today. And obviously, if you want cloud, if you want to put your metrics and events and you replace your legacy monitoring systems and just use our cloud for that, then yes, we will sell you our cloud capacity as well. And if you look at our pricing, you will find that there's a huge ROI. Companies love to replace their old and expensive monitoring solutions with our product just because it is a lot cheaper and a lot better than what they were able to do before. So in a nutshell, market-leading time series platform built specifically for metrics, events, and other time series data. Fastest time to awesome, and we allow you to take action while it matters. And it is super fast, super scalable, and highly available. So now it's time for some customer stories, and I think we are tracking very well on the time. So I will just take a few minutes to talk about our customer base and also talk about some of the stories we have. So if we look at our customer base, and this is just a subset of our customers, we can divide our customer base into three things. So as I mentioned earlier, if you recall, we are one platform for metrics and events, but these metrics and events can then be used for multiple things. So at the bottom, you will see our most popular category: infrastructure, application, and business process monitoring. These are the companies who are monitoring their on-prem infrastructure, their cloud infrastructure, their hybrid of on-prem and cloud infrastructure, their virtual machines, their Docker containers, and their Kubernetes clusters. And also, some of them are correlating that information with business processes. They are correlating that this Kubernetes cluster is managing my incoming orders, and is my order SLA fine with my business partners, or do I need to spin up another instance, right? So all that correlation is happening for some of these customers as well. And then the second tier is IoT monitoring. You will see some of the very popular names today. They use us for monitoring their speeds and feeds for their sensors and devices. And then on the top, you will see real-time analytics. And real-time analytics means that once you have these metrics and events, you're trying to make sense of what's happening, and then you're trying to analyze, maybe do a dashboarding on top, or try to send that analytics into where it can be the next best step can be taken on top of that analytics. So a lot of, instead of monitoring, it becomes more of an analytics use case. And we have some of the biggest customers in the world, biggest companies in the world today using us for real-time analytics as well. And just to clarify on what we mean, and when we say some of these terms, we have some customer stories as well. So SAP Ariba uses InfluxData, and InfluxData, as per them, was easy to implement and is now the primary data store to collect metrics and events for SAP Ariba operations. And InfluxData provides the basis for all the visualization and alerting that is critical to our business. So if you're not familiar with SAP Ariba, Ariba was an acquisition by SAP, and they have one of the largest platforms in the world today for procurement, visibility, operations, and optimization. And underlying, they run a very complicated or complex operational team, which is basically monitoring the health of their platform, because this platform is serving tens of thousands of other companies. And it is very important for them to make sure that this platform is always up and running, and they are meeting all the SLAs that they have promised their own customers. So they are using InfluxData to make sure that their platform is always up and running. And on the next slide, we have Tesla, which also owns Solar City. So you see the panels here, and Solar City is a customer of ours, and they monitor the systems and sensors across solar and battery installations, providing visibility and insight into energy usage and maintenance. So Tesla is not the only company. We have actually dozens of other companies, and Tesla is probably the biggest name. and that's why they are on the slide. But there are other companies who are monitoring water coolers, monitoring utilities, electric consumption, water consumption, and all that is being powered by InfluxData as well. So a lot of IoT consumption management, analytics, IoT data getting absorbed by Influx time series platforms. We have many stories around that. All right, the next story is about Siemens. And Siemens, large company, they sell wind and gas turbines to large corporations and municipalities, and they provide monitoring as a service. So you buy the turbine, and as another service, you can buy the monitoring of that equipment as a service as well. And that will give you the health usage performance of the the hardware. And Siemens is using InfluxData as a key metric store for this SaaS platform. So the SaaS platform, which is then used by the customers to monitor their own turbines, is underlying infrastructure is InfluxData, which allows customers to get their information via REST API. So this is all conducted in real time, and the data is streamed from each turbine to their cloud services as well. So very real time, very insightful, all in time series data, which you do not need. It's not relational at all. It is all performance related informational data, and Siemens uses InfluxData. The next story is local, closer to home. Wayfair is an e-commerce giant, and Wayfair is using InfluxData to monitor system metrics and events. And the goal is to marry these with business process events and provide better business insight and competitive advantage. So this is a great example of monitoring user behavior, how much time you spend on the page, what did you buy, what did you put on the cart, and combining those business level stats with your monitoring stats, and then making some meaning out of it. So great way to correlate metrics with events and then convert that into business insights and competitive advantage. All right, so this is the last slide before we go into questions. And this is a summary slide, in case you're still confused about our mission. As I mentioned earlier, we as a company, InfluxData, is singularly focused. There is only one focus, and that is to be the modern engine for metrics and events. We want to be everything to time series data, a company that handles time series data like nobody else can. And our focus is developers and builders. And I say developers very generically. In essence, it is admins, application developers, site reliability engineers, any of the functions that are involved in building, maintaining, and operating an application infrastructure. And then the difference is we are purpose-built. We are built for time series. We are built from ground up for time series. We deliver the fastest time to awesome and real actions in real time. We have the best traction when it comes to time series platforms, 150,000 unique active deployments, over 400 customers. And another data point is that over 400 customers in about a year and a half. So our open source community is very vibrant, and that is translating into a significant number of customers adopting our commercial solutions as well. And I believe we have one more poll before we open up for questions. All right. If you're not using time series platform today, do you have any plans to use them in the next 6 months?
Hi, Navdeep. So 78% of the audience says no, 22% says yes.
Excellent. All right, so with that, back to you, Marcus, for any questions that might have come up.
Yeah, thank you, Navdeep, for this really informative session and those impressive customer stories you presented to us. According to the tool, there are no questions so far. Maybe let's give the attendees some seconds to enter questions. If they were too focused to the session, so they didn't enter any questions. Can we get any questions here? Doesn't look like it. So thank you again, Navdeep, for your session. I have to announce and to everybody that there will be another Pass Marathon at the end of November, last week of November. The next Pass Marathon will be an analytics edition. So everybody involved into analytics could attend or should attend the Pass Marathon at the end of November. And with that said, I want to thank you everybody for attending. Thank you InfluxData for sponsoring the Pass Marathon, and thank you Navdeep for your session.
Thanks a lot, Marcus.
Bye-bye, everybody.